Hello everyone, my name is Zixiao Wang.
My name is Shushen Wang.
Today we are going to introduce our project, a log-based kitchen safety monitoring system for elderly care. So in the context of an aging population, there are more and more old people are choosing to live alone. So kitchen as a high-risk area, it has a lot of dangers, such as high temperatures or smoky full of the whole kitchen. So we need the traditional monitoring system are not adapt to the modern complex environment. So we need to create a new and available intelligent monitoring system to take care of these old people. And my partner Shushen Wang will introduce which technique we use in this project.
To reach this objective, we use the cross-platform and technical stacks. For the hardware, we use the ESP32 to collect data for the kitchen in real time, and all kinds of sensors, volume and sensors, and lighting sensors, and humidity and temperature sensors. And, for the artificial intelligence, we use isolation forest algorithm for the kitchen anomaly detections. And we collect data and train the model and use the model we have trained to detect the environment data in the kitchen. And, meanwhile, the yellow V8 and the medium pi are used for the human gesture recognitions. The content of the project is showed by a website.
This device will used in this project. So we use this sensor to collect the data of temperature and humidity. This is photosensitive sensor. We use this to measure the intensity of light. This is sound sensor. And we collect images and analyze activities by this camera.
For data collection, our system uses both environmental sensory data and visual input data collected in a real kitchen environment. The environmental sensory is based on the ESP32 platform, which collects the temperature, humidity, light, and sound data through the collected sensors. In the anomaly trained CSV, the ESP32 samples environmental data approximately every 2 seconds. The collected readings are transmitted to the Python AI modules through the serial communications in JSON format, and then stored as the CSV files for the further analysis and anomaly detection. Open the raw data.png. The normalized sensor signals show the variations trend of the temperature, humidity, and light and sound over time. In additional environment sensoring, the system also uses a camera to collect live video streams, and we can see in the person detector.pythons. The visual input is processed in real time using the yellow V8 for person detection. In the gesture medium pi .pythons, the Python medium pi is further used to hand gesture recognitions. This vision modules used the pre-trained modules, so no additional image trained data science was required in this project. For data processing, several pre-processing methods are applied to improve reliability. The physical boundary filtering removes impossible sensor readings, such as humidity values above 100%. To increase the short-term sensor noise, the rolling the median smoothing is used because it is more robust to impulsive noise, better preserves the sudden environmental change than moving average filtering. After pre-processing, the sliding window statistic feature extract was performed, as shown in the anomaly feature.png. The anomaly signal were segmented into the short windows. The mean and the standard deviations were calculated for each window. The mean represents the average environmental condition, while the standard deviation reflects the signal fluctuations and stabilities. The abstract the vectors were then used as the input as isolation anomaly detection mode. Isolation forest was selected because the kitchen anomalies are relatively rare, making unsupervised anomaly detection more suitable for the supervised classification. To evaluate the systems, the scenario-based testing was conducted using temperature, humidity, light, sound, and combined anomalies. Most anomaly classed was classified correctly. The proposed system achieved an over accuracy of the 91.4%. Temperature, humidity anomalies achieved perfect precision and record, while the sound-related anomalies were more difficult to detect because of the background noise. Now I'm in the school's accommodation kitchen, so I do the demo now. And first we can see it shows occupy. I'm here. I hit. We can see it shows empty. So it can change if there is persons in the kitchens. First I start gestures. 4 different gestures means 4 different means. The first one is the open sound. Yeah, it means something emergency. It's the help gestures. The second one is the fist. It means the cancel arm. Cancel arm is there is a wrong warning. Everything is safe. The next one is the scissors. Yeah, it stops automatic arms for a short period of time. And next one is the sum up. Yeah, it's safety confirmation gestures, and yeah, all the gestures have showed. Now I will introduce 3 different heat charts. The first one is the kitchen environment. This section overlays the 4 different metrics: temperature, humidity, light, and sound levels. And the horizon axis is time. The vertical axis is the value. Every time Spring pushes sensor data, a new data point is added. We can clearly see that the changes and abnormal fluctuations of all the kitchen environment indicators. The second one is the AI anomaly monitoring. There are 2 metrics. One shows the anomaly status, 1 for the abnormal and 0 for normal, and the other is the abnormal score. The higher score, the higher the potential risk. By comparing to this, we can tell whether anomaly happened occasionally or keep triggered continuous alert. The last one is health score over time. Only one matrix is displayed, and ranging from 0 to 100. A higher score means a better overall the environmental health condition. We can compare it with the environment and normally to check if the health score drops when abnormal fluctuation occurred. Next, I will try to change the environmental conditions. Because this of school's combination, it's hard for me to change the environment condition. So I have to use my phone as a flash lightning to change the lightnings as the examples. Now I will open the flashlight. We can see, yeah, light abnormal. So and the health score has dramatically decreased. The second one, I will change the sound. Yeah, the sound abnormally. Yeah, it has changed dramatically, and the health score is just 60 or 70.